Hey everyone, Jerry from Llama Index here, and today we'll talk about an advanced RAG technique that allows you to do dynamic retrieval, or in other words, figuring out whether to retrieve specific top K chunks from a document corpus or returning the entire document. Different types of retrieval might be more suitable for different types of questions. For instance, if you're trying to ask more simple questions, like, where does the specific person do action Y, then you might want to do more specific, like top K retrieval, which is standard in a naive RAG pipeline. However, if you're trying to actually ask something that requires the content of an entire document, like how did Tesla do in this financial year, you might, for instance, want to return the entire 10K document into the context window. This is increasingly more feasible with both longer context windows as well as lower costs and latency and actually running through large amounts of context. And ideally, you want to unify this into a single query interface. So we'll show you how to build a dynamic retrieval mechanism that can do both chunk level retrieval and file level retrieval with LlamaCloud and workflows. So we can go into this diagram to take a look at what this agentic architecture would look like to help you do dynamic retrieval. First, the core is at this thing that we call a router query workflow. And it's a simple router prompt, which takes in an input, and then depending on the properties of that input, decides to route it to either a chunk level retriever, which returns specific chunks from documents, or a document retriever, which returns entire documents from your knowledge corpus. These retrieval endpoints are indexed through the LlamaCloud interface. And so LlamaCloud provides you out-of-the-box ways of doing both chunk level and document level retrieval. At the end, regardless of what retrieval endpoint you pick, you take in all the context and feed it to an LLM to synthesize a response. The outer layer, actually, we can wrap this with some sort of agentic reasoning architecture, where instead of directly feeding the query to a router, you can actually feed this to some sort of chain of thought layer first, which will iterate through the different subsections of this question and decide to call this router prompt as a tool. And so by wrapping it in this overall, multi-step reasoning layer, then you also get the properties of being able to break down more complex questions into simpler ones. So let's walk through and see how this works. First things first, we will be loading in 5 Apple and Tesla 10Ks and then uploading them into LlamaCloud. These are basically, the 10K documents for Apple and Tesla from 2019 to 2023. And you can see an example of what this data looks like right here. 10Ks are a pretty popular data source for building RAG demos. And so you can see there's a lot of text, there's a lot of tables as well. And LlamaCloud has out-of-the-box capabilities, thanks to our parsing technology, to parse that text into, or parse the document into well-formatted text and tables in Markdown format. In LlamaCloud, we can see that we've already created an index containing these Apple and Tesla 10Ks. So just to give you an example, all you have to do is drag and drop these files and create a new index, and this is what you get. So by clicking into one of these files, you can see the raw document. You can see the parse document, which is basically Markdown, right? And you can see what the chunks look like. In this case, we specified page level chunking so that every page is a separate chunk. And here, for instance, is what the table of contents looks like. And if you go to the overview page, you'll see this is how we actually plug in this index into the rest of our agentic workflow. It gives you back retrieval endpoints that you can call in order to get back relevant context over your data. So now we will go in and define the core router workflow. And so maybe taking a step back, we'll actually do an integration. We'll showcase an integration with Llama Trace, which is a collaboration that we have done with Arise Phoenix, where once we run these workflows, you can actually log all these traces to a hosted instance that's like hosted Arise Phoenix. It's a pretty comprehensive observability and evaluation tool that allows you to capture all these different logs and traces from the workflows and help you see them in a really nice display. So we'll show you that in just a bit. But first, let's actually define the workflow. So in this section, we are going to define the sections that you need to actually build a router workflow. This box right here just shows you some core prompts and also Pydantic classes that you're going to need. One item here is the router prompt, where you tell the LLM to basically decide which choice to pick given some information about these choices and given the input task. And so we are going to use this router prompt to decide whether to pick chunk level retrieval or file level retrieval, depending on the question. The format string right here tells you how you should format the output. And basically what you want here is to basically tell the router prompt to format your choices in some sort of structured representation. Here we see that we have the answer classes. And so the answer is defined as a Pydantic base model. And when you pick a choice, it has you output both the choice index as well as a reason for it. Here you can output multiple choices instead of just a single choice. And so when you do a router, you can select multiple choices in this list. And then the router output parser basically is an object or a class that you apply at the end of the LLM call. And so after the LLM returns some output, you can use the output parser to basically parse that string output into this Pydantic object. So in this case, we actually are not using function calling. So most LLMs these days, or many of them, support function calling where you actually get back a structured output through the LLM API. But this is actually a more general form where instead of having to use the tool interface of the LLM directly, you basically are prompting the LLM to basically output stuff in this schema. Of course, this doesn't necessarily guarantee that it will output stuff in the schema, but most models should obey this format these days. And then we're going to use this parser object to then convert the LLM response into a structured output. You can also do this with function calling if you want. This is just showing you what the current notebook does. So once we have those core components, we can define a router query workflow. And this is going to be the first workflow that we define, and it's going to consist of the following steps. Given a question, we are going to choose basically what kind of underlying query engine, whether it's file level or chunk level retrieval, to call based on the input. And then we are going to query each one of the choices depending on which one was selected. And then we are going to synthesize a final response based on the results from the queries above. Similar to how we've defined workflows previously, a workflow is basically defined as a Python class plus a set of steps, and every step passes events from, or listens to input events and emits output events. So you can pass in whatever initialization parameters that you want. Here we just pass in the different choices or the query engines that we want to specify. And so the query engines, by the way, we'll show this once we actually initialize this later on. The query engines are basically just full RAG pipelines defined over the different retrievers that we define. In this case, the retrievers are, again, the file and chunk level retrievals. The first step here is we are going to, given the start event, which contains the input task, pick the right query engine. So we are going to use the router prompts and plus the output parsing or structured output parsing to basically tell us, what exactly is the selected choice, what choices are selected by the LLM. Given those choices, we are going to then call the next event, which will basically help decide, the query engine that we want to query. And so this just returns a choose query engines event, which takes in the output and the query. And then in the next step, we are going to actually call the relevant selected query engines. You could choose to break this down into separate events, actually, so that depending on the number of query engines you decide to call, you actually emit one or more events. Here, we just call all the query engines in a single step. And then the last step here is, given that we called all the query engines, try to synthesize the response. And so, given kind of the input, we are going to call the LLM one more time or use some sort of summarizer prompt to basically get back the final response. So this is the overall workflow. And notice that it does depend on this query engines piece, which requires us to actually pass in the specific endpoints that, or the specific choices that we want the router to pick between. And as mentioned, we want the router to be able to pick between chunk level retrieval and file level retrieval. So we are going to define a LlamaCloud retriever over these different documents, or define two different LlamaCloud retrievers, and then plug this into the router. So we are going to integrate with that index that we defined, for the like Apple and Tesla 10Ks. And then notice that we defined two different types of retrievers. So here, this is index as retriever with retrieval mode files via content. And then here, there's another retriever with retrieval mode chunks. This gives you back the two different retrieval interfaces. One will return the most relevant chunks given the input, and the other will return the most relevant documents. We'll plug this both in. So a retriever takes in an input and returns the most relevant chunks. By plugging this into a retriever query engine, then this takes in an input and synthesizes the answer, the retrieved chunks, using an LLM, and actually gives you back the final answer. So by plugging in a retriever into this, the retriever query engine, you get back an end-to-end pipeline. So we have these two query engines, and then the last step is to actually define, some descriptions around these query engines. Because we're passing both as choices into this router, the router needs descriptions of what these query engines actually do in order to differentiate between the two and prompt the LLM to decide which one to pick. So we are going to define the two different descriptions of these query engines. Here we have the document retriever description, which basically says, let's synthesize an answer to your question by feeding in an entire relevant document as context. And so it's best used for higher level summarization options. And so try not to use it if the answer can be found in a specific chunk of a given document. The chunk level retriever will say, synthesize an answer to a question by feeding in a relevant chunk as context. And so it's best suited for questions that are more pointed in nature. You were basically trying to guide the LLM to help it really understand what types of questions are better suited for the document retriever and which questions are better suited for the chunk level retriever. Better prompting probably would include actual few shot examples of questions and answers, and also maybe negative examples as well. In either case, once we've defined both the query engine as well as the tool descriptions, we plug this in along with the descriptions into this router query workflow that we defined above. So we could stop there. This already gives us a router workflow, which can dynamically decide whether to query file level or chunk level retrieval. But we are going to go one step beyond. And the one thing here is that this doesn't really have the capabilities of doing, for instance, chain of thought processing. What if the input is actually somewhat complex and you want to be able to decide whether to break this task into more simpler steps before deciding which retrievers to call for each step? For instance, if you ask, what is the revenue of both Apple and Tesla, you probably want to break that into two different questions. What is the revenue of Apple? And also, what is the revenue of Tesla? And then ask those independently against this router system. So we'll wrap it with this kind of agentic workflow. And so we're actually going to define a router workflow or an outer workflow that we plug in the sub workflow or the router into. This agentic outer workflow will be able to take in a question and then basically do some sort of function calling to dynamically break down that question into individual substeps and keep iterating until all the sub questions are answered. So this is very similar to our implementation of what a function calling agent is or what a React agent is. And if you want additional references, you should definitely check out the notebooks where we show you how to basically build a React or function calling agent from scratch. And it's very similar to that. And it will consist of the following steps. First is, given an input, we are going to append that message to the chat history. And so we are going to feed that chat history into the LLM along with a set of tools. The tool, there's a single tool in this case, and that's basically just the underlying router workflow. And the LLM will decide whether to call that tool or whether it's done and also what is the input to that tool. By deciding what is the input to that tool, because most of these LLMs have some sort of function calling capabilities, it will implicitly be able to decide whether to break this more complex question down into simpler calls, because it might call the tool with a more simple input. And then the next step is to actually call the tool and run it. So we run the router workflow, and we'll basically dispatch the calls to the tool and call the tool. And then we finally gather all the results from the tool calls. And then we finally feed it into an LLM for the final response. It's basically a while loop that keeps running over the set of tools until the LLM implicitly decides that it doesn't need to call any more tools and it can figure out the final answer. So you can see how we define the workflow right here. We plug in the RAG workflow. Basically this is the underlying workflow that acts as a tool for this outer agent workflow. And then we also, we plug in this RAG workflow as a tool. So we wrap it with what we call a function tool. And this basically is an abstraction that allows it to be fed into an agent. This workflow has the following steps. So the first step is prepare chat, which basically takes in the input and adds it to the chat history and emits an input event. The next step is we actually we call the LLM with tool calling. So we plug in the RAG workflow tool. We use one of the functions that we have within LlamaIndex, which is a bit lower level on the LLM side, and it's called AChat with tools. And this basically allows you to not just pass in a general chat completion input and get back a response. You also plug in the set of tools that you want, and then you can actually parse the output tool calls. And so by calling AChat with tools with this tool, and then calling get tool calls from the response, you can directly parse the set of tool calls that it was able to call. And these tool calls are basically calls to the underlying router. If there are tool calls, then we actually emit gather tools event. So we process these tool calls and continue to, as in we actually run the tools and then get back the response, and then we keep iterating from there. If the LLM decides that there's no more tool calls to be done, so that generally means that it can answer this question without needing to call the router anymore, then it'll just return the final answer, and then this entire workflow will stop. So that's basically how it concludes execution. If there are tool calls to be run, then it'll call dispatch calls, and then for every tool call, it'll call what we call a tool call event. So this part, you can see that instead of just sending one event from dispatch calls, we send n events where n is the number of tool calls. And every tool call event will be routed to a specific step, which is basically called call tool. And then it will be responsible for calling that specific tool with that set of inputs. So for instance, if you decide to, what is the revenue of Apple and Tesla? The LLM might actually decide, especially those LLMs that support parallel function calling, like the OpenAI models, to do two tool calls at once. One to call the underlying query engine with what is the revenue of Apple, and the other, what is the revenue of Tesla. If it decides to actually call two tool calls at once, you're going to be emitting two events right here. And then each of those two events will get passed to call tool with what is the revenue of Apple and what is the revenue of Tesla. We will run each of these workflows independently, get back an output, and then emit a tool call event result. So our responsibility after we call all these tools is to then gather all these tool calls. And then the high level idea of gather is to wait for all the tool calls to complete, and then finally append the final response to the chat history. So gather is a step that basically has a call called collect events. And collect events basically allows this step to wait until all the underlying tool calls have completed. Collect events will return none if you haven't reached the count that's specified here. And this count because the LLM, right, when it returns the number of the set of tools it wants to call, gives you that number already. And so you're basically waiting until you actually finish calling all these tools before you can then proceed. So if it hasn't filled up the counter, you'll return none. And then if it has, then you'll continue to the end. For every tool event and tool events, we're going to add the tool call and then also the output of calling the tool to the chat history, and then go back to the input event. And remember, the input event just goes back into chat, and then we are going to restart this tool calling process. And so, let's say we answered the questions, what is the revenue of Apple and what is the revenue of Tesla? We added those to the chat history. We go back to the chat step. We call the LLM again. The LLM has full visibility over the entire chat history. The original question is, again, what was the revenue of both Apple and Tesla? If the LLM sees that both of those questions have already been answered in the chat history, it will probably decide to not call any more tools, and then it will respond. It will return a stop event. So what I just described to you is actually the second step beyond just this initial router layer on top of both file and chunk level retrieval. And it's actually optional if you don't want to implement it, but it basically is just generic, a simple agent architecture that does chain of thought processing that you can basically plug in whatever workflow you want. And then this thing will always be able to call that workflow as a tool by doing chain of thought over it. So let's define this entire thing. We have this router output agent workflow, which is this entire agent workflow. And then we can visualize what it looks like right here. This is just an illustration of the outer workflow where, again, given a start event, shows prepare chat, calling the tools, dispatching the tool calls, actually executing the tools, and gathering the results. And then, basically iterates until it is done. And finally, let us run some of these workflows. So we are going to try out some of these example queries, like tell me the revenue for Apple and Tesla in 2021. And if we just go through the logged outputs, you can see it's actually basically doing exactly what I said. First, it produced input event, then it is going to call the LLM and basically looked at what are the underlying tool calls I need to execute. And you can implicitly see what calls that it decided to execute here with the outputs. It calls the function query workflow with the message Apple revenue 2021, and also the query workflow with message Tesla revenue 2021. And it's emitting both of these at the same time. So the LLM actually decided to do parallel function calling after seeing the input. Next, because we call the underlying router, the router again decides whether or not we want to answer this question using file level retrieval or chunk level retrieval. And choice 1 is document level retrieval or file level, and choice 2 is chunk level. For both of these questions, it said it picked choice 2. And here the question Apple revenue 2021 is pointed in nature. So the LLM, probably based on prior knowledge, figured this is something that probably only requires a specific lookup from the document. So you don't need the entire document. And so using a relevant chunk as context is more appropriate. Same thing for Tesla revenue 2021. Then it will gather the responses, synthesize the answers, and then finally it will call gather, running step gather, and give you back the final response. Apple's total net sales, and then Tesla's total revenue. The formatting is a little messed up, mostly because of kind of like the italics and stuff, but basically it gives you back the right answer. There's another section which is tell me the tailwinds for Apple and Tesla in 2021. And then here, it actually picks choice 1 or document level retrieval because the LLM, based on prior knowledge, just decided that generally it probably needs to understand the entire document to actually get enough context to answer the question. This part is maybe a little bit more ambiguous, so it's understandable if the LLM decided to choose either chunk level or file level. And then the last thing I want to show you is just something that's very clear where you need the entire document as context. If you ask a question like, how is Apple doing generally in 2019? This is pretty clear that you basically should probably look at the entirety of Apple 2019 as a document. And you can see here the selected choice is choice 1, or document level retrieval. This question requires a general summary of the entire document and is best suited for higher level summarization options and synthesizing an answer by feeding in the entire document as context. And then you can see what this response is. So now we can take a look at how these traces are actually logged in LlamaTrace. And I won't go through all the details, but basically you can see that these two workflows are actually logged right here. We asked, tell me the revenue for Apple and Tesla, and then also how is Apple doing generally. And you can basically see that we logged the entire call stack right here. You can see every single step through the workflow, including both the outer agent workflow as well as the router, and you can see the inputs and outputs to every step. So definitely check it out, especially if you sign up. And basically all your workflow steps will get logged to this tool. Great. That's it for today. There's some more sections over here, but this is basically more advanced. And you can basically do it as an exercise to the viewer. And so, yeah, stay tuned for more content. There will be more advanced RAG sections along with additional sections on report generation. And so thanks and see you next time.